welcome to the video. We are going to solve print matrix in diagonal form, in diagonal pattern. In this question, we are given a matrix of n cross n order, and we have to print it in diagonal format. But there is a catch. You may face some problem while understanding the concept based on the description of this question. So there are conditions when you can move diagonally upwards or downwards, and there are conditions when you can move only like right or down, okay, downwards or right without diagonal movement. So there are two conditions only when you will have to move diagonally upwards or downwards. Otherwise you'll see the example one for 3 cross 3, but when 2 cross 2 will come, you may face some problem. And similarly when n will change, okay. So there are only two conditions when you can move diagonally. See, there are two conditions. You can move only diagonally downwards or diagonally upwards in this question, example 3 cross 3 matrix. Cool. So if there are rows below and columns to the left, see as a two element. There are rows below to it and column leftwards to it. Okay, you have column left to it and rows below to it. Only then you can move diagonally downwards. You can move diagonally downwards. And there's one more condition when you can move diagonally upwards, when there are rows above. Take the 7 as a case. There are rows above to it, 4 and 1, okay, the first row and second row, and there are columns to the right, like this second row and third row. Only then, if we have rows above and columns to the right, rows above and columns to the right, only then you can move diagonally upwards. And apart from these two conditions, you cannot move diagonally. You will have to only move downwards or rightwards based on the conditions, based on where you are standard. So we will solve this question, okay, with our approach, with my approach, and it is very basic approach. You will face no problem in understanding. Let me start. So first of all, I'll create two variables I and j, initialized with 0, so as to take the first row and first column, the first cell of the matrix, first cell of the matrix. Cool. Okay. Now two variables r and c. R will be the length of the number of rows in the matrix, and c will be number of columns. Number of columns, and columns will be matrix zero. Length of matrix 0 will give us the column. So we could have taken just r, and r and c both will be same since it is a square matrix. But I've taken different variables for the simplicity. So first of all, I will create a result variable in our matrix format. And this will store the first cell ij. Can give 0 0, but I'm giving ij since I am j store only zeroth value at this point. Now there will be the condition that we should be inside the bounds, which means I should be less than equal to rows, and j should be less than equal to columns. Cool. We are inside the bounds. We are not going outside the bounds. The moment we will go out of the bounds, we will come out the loop and will return our answer, which we'll get by calculations. Cool. Now, what we will do in calculations, it is pretty straightforward. Okay. Now, first thing, we will check if there is a column to the right. If there is a column to the right, if j plus 1 less than c, if j plus 1 less than c, if there's column to the right, we'll move right side and append this cell value to the result. If there's a column to the right, we can move rightwards. And believe that here we are only checking if there's a column to the right, and we are not checking if this is row upwards or not. We'll check that later on. Okay, this is the case. See the element 3 in the image. You have columns to the right. Sorry, columns to the right. You can see this is the one cell 1. You have column to the right. You may have cell below. You may have, okay, number of, okay, columns in the rightwards. That does not matter. If you have column to the right and there's no cell, you'll have to move rightwards. But if that's not possible, there's no column to the right, which is the case with this 3 value 3. In that case, we will increment the row value. We can move downwards. See at the value 3, there is no column to the right. You can only move downwards. You can only move downwards. In that case, we'll appended incremented the value of row, and we will append this value of matrix, this cell value. Now we check this condition. Now there will be a case when you can move diagonally. When you can move diagonally. And when was the case? If you can remember, I told you that if there are rows below, if there are rows below and columns to the left, if there are rows below and column to the left, see the value 2. There are rows below and there is column to the left. In that case, you can move diagonally downwards. Similarly, for value 6, there are rows below and column to the left side. Okay, this one, first and second column is remaining. In that case, you can move diagonally downwards. Now while I plus 1 less than r, there are rows below. Okay, you're not in the last row, and j minus 1 greater than equal to 0, which means you have columns to the left. You are not in the last row and you are not in the first column. Cool. In that case, you will decrement I by 1, increment j by 1. Then you can move diagonally downwards, incrementing j with 1 and reducing I with 1 will give you diagonally downward position. You will append this position in the result. Now, this was the case when you are moving downwards. There will be case, there will be a case, okay, if there are rows below, you are in the upward direction. If there's rows below, see at example the value 4, cell 4, okay, the value cell with number 4, you can move diagonally downwards. Now, okay, we have taken that condition, but we'll take next condition. If I plus 1 greater than plus 1 less than r, if I plus 1 less than r, which means if there are rows below, you are not in the last row, you'll increment I to move to that position. I was right. So if you see the cell with value 4, there are rows below. We are not thinking whether we have value columns in the left or right direction or not. We are only thinking if there is row below. Okay, in that case, increment the row with 1, number of rows I with 1, and append this cell value to the result. It's I. Now, the other condition, if there is no row below, if there are no rows below, you are already in the last row, then there will be a condition you can move rightwards. You can move rightwards. Okay, you can move rightwards. You will increment j with 1 and append this value to the result result value. When is this case? When you are at the cell with value 8. See, you are at the cell with value 8. There is no rows below, but you can always, but from this position, you can move rightwards. So you incremented j with 1, you move from 8 to 9, and you appended this value to the matrix, the result matrix. And now there will be a position when you have to traverse diagonally upwards from 7 to 5 to 3. Okay, this will be the condition, and this was when there are rows above. See at value 7, there are rows above. You are in the last row and you have two, sorry, yeah, if you're in the last row and there are two rows above and columns to the right, you are in the first column and there are two columns to the right. If there are rows above, there are columns to the right, you can move upwards. And how we will represent that? If I minus 1 is than equal to 0, I minus 1 greater than equal to 0. There are rows above and columns to the right. Columns to the right. Columns to the right. Okay, you can move upwards and you can move rightwards also. In that case, you will decrease the value of I, which is the row. You will go upwards in terms of rows, and you will go rightwards in terms of column by incrementing the j with 1. At this point, you have moved diagonally upwards, and you will append this position to the result. This still value multiplied to the result. And now by this point, we have covered all the necessary cases. You have covered the case when you are moving diagonally downward, diagonally upward, right side, down side, left side. Okay, you have covered everything. At the end, at this point, will be the case when we move out of the bound. Either we have exceeded the number of rows or we have exceeded the number of column. Okay, and in that case, we will move out of the bound and you will return the result which you have storing so far. Okay, there is some issue in line 19. Okay, what is that? Okay, you sorry, this was diagonally downwards, so we'll have to increase the row and decrease the column. Okay, I will pause the video and we'll fetch. So this is the condition. I have taken both the values and that will restrict ourselves to move rightwards and downwards. So only to, yeah, that was the culprit. So as you can see, since it is very naive solution, it took less than more than 1 second, and also it is Python. It is not compiled, so it takes more time. But see, it is the best and easiest approach which you can solve this question. Otherwise, this description of question is not clear, and you may face problem if you set your approach for one square matrix. You will face for a different value of n. You may face. I'm not saying you will, but you may face. So this is the easiest approach, very naive and basic approach, where everything is detailed and every cases are covered. So I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.